In the last video, I did mention Comet Shoemaker-Levy 9, which was the impact. He actually hit Jupiter. And by the way, this was something that was the very first time in human history that we actually witnessed this. I mean, we theorized that objects in the solar system hit other objects in the solar system, but this is the first time we actually witnessed it. And during July of 1994, all the telescopes on the planet, including the Hubble Space Telescope, were aimed at Jupiter to record this monumental impact. And there's one example. There were actually several pieces of this comet. It actually broke apart into numerous fragments. And there's one example, and I think I mentioned this before, that when this thing hit, nobody really knew what was going to happen. Jupiter's so massive. Was it going to leave a scar, a little impact or so? And indeed it did. And these impacts actually lasted for months and months and months. Since this happened, there have been other impacts that we've actually witnessed, where a comet or an asteroid hit Jupiter, and we've seen the same type of thing where there there's an indication in the atmosphere. But certainly since this time, the Galileo spacecraft was orbiting Jupiter for like I said, over a decade. I mentioned this in the last video. I know I mentioned a bunch of stuff. Jupiter does radiate more energy than it receives from the sun, and the theory of why this is there's actually the core is still is still cooling off from the original formation of Jupiter. It's such a massive object, even though it's 4.5 billion years old. It's still cooling down, and so that material as it cools off is actually giving up heat, and so that's of course a form of energy. Jupiter would have to be almost 100 times the mass that it currently is to become even the smallest stars that we know of in the galaxy or in any of the galaxies. So no, actually, when you look out at the Milky Way, our collection of stars that we that the sun is part of, the 100 billion stars that is called the Milky Way galaxy. And there's many other galaxies out there in the universe. But anyhow, about half of our stars in our spiral galaxy are actually binary stars. There's two stars in the solar system. Sometimes there's more than two, but almost half of the stars exist as binary stars. Just to let you know. So Jupiter would have had to, like I said, accumulate almost 100 times more mass than it currently has for it to become a star. All right, and that's because it's not big enough for the fusion process to take place. Hydrogen with enormous pressure, hydrogen, the simplest element of the universe, compresses down to become helium, and that's called the fusion process. All right, so using the Galileo spacecraft and observations over the years, this is the what we think of as the kind of a cutaway of the interior of Jupiter, and we do think that in the core. There is this material called metallic hydrogen. This hydrogen that is so compressed, so there's so much density there that it's actually turned into a metal type of form. A metallic form. Sorry. Let's see. Let's see. Are we talking about? Yeah, so they're just saying that. So this is just talking about the fact that Jupiter just doesn't have enough mass to be a star. It would be considered in modern in modern terms, it's actually called a brown dwarf. It's of course a planet, but these brown dwarfs we've actually seen these in other locations within our galaxy, so these things are just not big enough to become stars, but they still emit some heat energy, but it's certainly not enough to cause the fusion process, which is the process that gives energy to all the stars. That's why stars radiate energy, is because of fusion. All right, let's get back to Jupiter. Again, the magnetic field is the biggest. Really the biggest of all the planets. It's the second largest magnetic field in the solar system, only second to the sun. And of course, it has these very similar to what like the Van Allen belts around the Earth. There are charged particles that get trapped in Jupiter's magnetic field. We can detect radio waves from those charged particles that are trapped in the magnetic field. Anytime charged particles accelerate, they produce radio waves, or they can produce radio waves depending on how fast they're moving. Jupiter's magnetic field extends way out beyond the immediate location of Jupiter, and in fact, part of it even goes out as far as the magnetic, this magnetic sphere, which is not really spherical, it's more of like a teardrop shape, extends much further than even the orbit of Saturn. So, all right. Now we'll talk about the moons. This is a little older. I think there's now 64 moons, possibly 65. Any ones that we find now are generally very, very tiny. The four largest moons actually are called the Galilean moons because Galileo discovered them around 1609, 1610. He's actually the one that named them. Io, Europa, Ganymede, and Callisto. That's actually the order that they are from the planet. Io is the closest to Jupiter. Then comes Europa. Then Ganymede. Ganymede is the largest of the Galilean moons. Actually, it's the largest moon in the solar system. And then comes Callisto. We'll get some nice pictures of these. We really saw. The close-up pictures came from the 1980s with the Voyager spacecraft, the Voyager 1 and the Voyager 2 spacecraft. So we have interesting things to say about each of those. And again, of course, the Galileo spacecraft spent a lot more time observing these, taking pictures of these over its long mission. There's some pictures of these are close-ups from what is this from? Probably from the Galileo spacecraft. All right, so again, these four are called the Galilean moons. Let's go over each of them. All right, so Io is the smallest of the Galilean moons. It's not the smallest moon, but it's the smallest of the Galilean moons. And in the 1980s, early 1980s, one of the engineers was observing the information, the pictures that were coming back, and noticed what looked like at first a plume of material, an actual a plume like you see from volcanoes. And it turns out that that's exactly what it was. In fact, Io is the most volcanically active object in the entire solar system. It's actually way too small to for it to be volcanically active. And so this puzzled people for a very, very long time. It turns out that the reason that it's so volcanically active is because of internal squeezing, basically tidal forces on Io due to its close proximity to Jupiter. Europa, I mentioned a little bit earlier. It has a very smooth surface, and because of its density, we think that it has a liquid ocean of salt water inside of it. Ganymede, again, the biggest. Ganymede kind of looks like somewhat like Mercury, like the surface of Mercury. It's very heavily cratered. And Callisto, which is a little bit darker in color, but is also very heavily cratered. All right, the densest. So we mentioned that already. The most volcanically active. So you don't see craters on Io because, of course, the surface of it is changing all the time. All right, let's see. So this is. This is Io again, showing the sulfurous surface of it. It's very orange in color. So I already mentioned this. The tidal forces are really what's producing it. There's a nice picture of one of these plumes. These volcanic plumes. These aren't the only plumes that we see in the moons in the outer part of the solar system, by the way. When we get to Saturn, there's a moon called Enceladus. We'll have a lot to say about that. And actually, the volcanic eruptions, some of the charged particles have actually been trapped in Jupiter's magnetic sphere, and this is kind of a cartoon picture of that. Europa. Has a very smooth, icy surface, and there's a very, very good evidence that there's liquid water inside. We actually see cracks on the surface of Europa. Hopefully, someday within our lifetimes, there'll be a probe that is sent. There's been a lot of talk about this in scientific communities. To send a probe and somehow that could robotic probe, of course, that would burrow through the ice and then swim around in the oceans of Europa and look for life. Even microbial life would be fascinating, absolutely interesting, incredibly interesting. Ganymede, of course, is I mentioned this already, the largest moon in the solar system. And notice it's larger than Pluto or Mercury. Mercury, which is of course a planet. Pluto, which is now called a dwarf planet. Ganymede is bigger than either of those. All right. So, and then Callisto is very, very similar. It's a little bit darker in color than Ganymede. Very, very heavily cratered. This is one of the rings of Jupiter. You can't see the rings from the Earth. They're way too small. They were actually first detected by. I'm sorry. I take that back. You can actually, with a very strong telescope, you can see them through a process called occultation. When starlight lines up from our vantage point on the Earth, directly behind these rings, you'll see the starlight change, basically twinkle, if you will. Not like the twinkling we see in the of the stars in the night sky. That has to do with our atmosphere. But the starlight changes, and that's because the starlight is passing through Jupiter's rings. Oh wow! I finished. Wow, that's actually that almost never happens. All right, so that's the chapter on Jupiter, and we'll turn to the next gas giant, Saturn, with its magnificent rings. next.